The agenda for today includes the concepts of model-based estimating. We're going to continue with looking at construction caliber quantities versus regular BIM quantities. We'll look at the evolution of an estimate, and then we'll take a quick tour of VICO Office and VICO Takeoff Manager. Finally, we'll discuss the benefits of using the model-based estimate during pre-construction and construction. So let's start by looking at this equation that we looked at last week, and we also looked at the week before. As we discussed earlier, quantities play a key role in scheduling and also estimating. This week we'll look at how these quantities can be used for estimating only, and how these quantities can be generated from the model, from a BIM model, such as an ArchiCAD model, a Revit model, or a Tekla model. Using these quantities at a higher level of detail will give you the ability to transparently and accurately communicate cost and communicate changes to the client, and make sure that your estimate is always up to date as the design progresses. So let's start by looking at the quantities a little bit closer. There is a big difference between construction caliber quantities and just regular BIM quantities. Construction caliber quantities are more accurate than just regular BIM quantities. BIM quantities typically have to be programmed into the application, into the BIM application for accurate calculations. And VICO spent the last 5 years with understanding how to calculate these quantities the best so that estimators can use it right away for their unit costs and for formulating their estimates. For example, if you look at a column in a regular BIM application, when you look at the column surface itself, it will give you all 6 sides of the column as the surface area of that component. In VICO, however, the application will understand that you only use the surface area to estimate the amount of formwork you need or the amount of cladding you need to install on the column. So it only will give you the 4 sides, as the illustration shows. Furthermore, it will also be able to differentiate between net volume and gross volume so that you can use those at different stages of your estimate. The same applies to, let's say, drywall. At the initial stages of the estimate, you only want to use the gross surface area of drywall to create your budget. But later on, when you formulate your GMP, you want to increase the accuracy of your estimate, and you will use the net surface area of the drywall. So being able to make that differentiator inside the VICO Office and with model-based quantities is really important, and that's what we call construction caliber quantities. So let's take a look at how these quantities are calculated and how they are used in the process. First, when you build a BIM model, you're going to build a BIM model representing different assemblies. You're going to have columns, walls, slabs, different types of objects inside the BIM model, which basically will be the equivalent of assemblies in your estimating system. Those assemblies are broken down into components, such as in this case, rebar, formwork, concrete for the column, and cladding. And those components can be also be the equivalent of different activities that you need to do. So by breaking these down, by breaking these assemblies down, you're increasing the level of detail of the model without adding more information to the geometry of the model. You're basically creating assumptions that you're going to be using in your estimates. The components will allow you to calculate the tonnage of rebar based on the volume of the column itself, the area of formwork based on the 4 vertical sides of the column, the amount of concrete you're going to need based on the volume of the column again, and finally the amount of cladding you're going to need based on the surface area of the column itself. So being able to use different quantity types for these different components is really important, and VICO Office and the process will allow you to extract those quantities accurately and as fast as possible from the model. Once you generate a list of components and link them to different quantities, you're going to be able to break those down to resource level if necessary. If you self-perform concrete, for example, you're going to be able to break that down to material, labor, and equipment to create an even more accurate estimate for, as I said, self-performed trades or trades that you want to negotiate at different level. Finally, you'll be able to group these components according to different zones. You can break down the model based on construction zones, based on your construction sequence, or you'll be able to break down the model based on estimating zones. If you have a lobby area, you'll be able to break down the quantities for that lobby area alone and create an estimate that will include the quantities from that area and will isolate the quantities for that area automatically. If you change the design, if the design of the lobby is different, you're going to be able to change the zone, the boundary of the zone, and update your estimate accordingly. This will help you give a new meaning to value engineering, because today value engineering is a negative term. It happens after design is completed. Suddenly you make the client aware of the cost, and you start stripping out the nicer parts of the design. When you have the ability to immediately give feedback to the client on design changes by combining quantities with areas, you're going to be able to perform value engineering as the design progresses, as opposed to at the very end. So this system allows you not only to give real-time feedback to the client, but also use the quantities for more than just estimating. Use the quantities for scheduling and use the quantities with production rates to generate a more accurate schedule with accurate durations and more accurate logic. The next step is to look at the evolution of the estimate. The design information that I just described is not always available to the estimator at the very beginning of the project. When you start your project, you just have a massing model available from the designer. You might not have the components broken down the way I just illustrated in the previous slides. And as this graph shows, the ability to make changes and the cost of those changes dramatically increases as the specification level changes. So the later you make the change in the design, the more it's going to cost, because the more you have to redesign. So it's very important that you get continuous feedback about cost and that you have an ability to continuously monitor against targets. Let's start with the first stage, in the concept stage, where you only have massing elements. At that stage, you might use zones, you might use rooms or mass elements to just define different functions in a building, in a design. So you could have a parking garage, a podium, and a residential tower represented with just massing elements. You could also break those down to functionality, so you could have the residential tower broken down by unit types and have a dollar per square foot associated with each unit type. And by using the model, you can get a quick estimate based on the geometry and based on the unit per square foot cost of the project itself. So you're working on a high level, you're just working with simple geometry and with dollar per square foot cost.